Hi, I wanted to take just a few minutes to explain the concept of scientific notation, how to put numbers into and take them out of scientific notation. So that's what we're going to do today. Okay? To start with, what is scientific notation? It's just a way of writing very large or very small numbers in a much more manageable way. You see, when you have a number like this, that's a lot of zeros. Same thing there. That's a really large number on top, a really small number on the bottom. Too many zeros. I'm lazy. I don't want to write all those zeros. So fortunately, we have scientific notation. And scientific notation is an easier way to write these very large numbers without putting in all those zeros, because all those zeros are doing is holding the place of the decimal point. And if they're just placeholders, they're not really important. So we can take them out of there by using scientific notation. Okay? If you're going to put a number into scientific notation, it's going to have two parts. The first part is the coefficient. The coefficient is the part in front. It's the number part. And then we have the exponent, and that's the power of 10. It looks like this. 2.57 times 10 to the negative third power is how we would read that. Milliliters. That's our unit. The coefficient is the 2.57, and the 10 to the minus third, that's the exponent. Every number in scientific notation is written as these two parts multiplied together, and the unit goes at the end, the very end of the whole thing. Pretty simple, right? Okay, so how do we write numbers in scientific notation? Well, let's start by taking a look at the coefficient. So the coefficient has some rules. It has to be greater than or equal to 1, but it has to be less than 10. What that really means is you can only have one non-zero digit to the left of the decimal point. Okay, so the number before, the first part of this number has to be between 1 and 10. It could be 1, it may not be 10, because 10 has two digits to the left. So 56.73 times 10 to the fourth, that's not correctly written in scientific notation, because 56 is bigger than 10. Same thing over here. 0.025 times 10 to the 12th is not correct scientific notation, because the 0.025, that coefficient is less than 1. So 5.912 times 10 to the minus 2 grams, that's correct. The 5.912 is greater than or equal to 1 and less than 10. Only one digit to the left. Now the exponent gives us some information about how big the actual number is. The size of the exponent tells us how many places the decimal point needs to move if I want to convert back to standard notation, for example. Okay? And the sign of the exponent tells me which direction to move the decimal point. If the exponent is a negative 1, that means the original number is smaller than 1. If the exponent is positive, it means the original number is greater than 1. And if you want to take a number in scientific notation and make it greater than 1, you have to move the decimal point to the right. And if you want to make it less than 1, you move it to the left, just like as if you were doing the conversions in the SI system. So let's take an example. Here's this ridiculously long number of meters. What would that be? Let's see, billion, trillion, quadrillion. So 1 sextillion, 241 quintillion meters. That makes me tired just saying it. I don't want to write all those zeros. So I'm going to take the important part of the number and I'm going to write it in scientific notation. Now I know this number is much larger than 1. So the exponent part of this is going to be positive, right? The coefficient will be just the digits that are important. The 1, 2, 4, and 1. And because the coefficient has to be greater than or equal to 1 and less than 10, I put the decimal point between the 1 and the 2 to make 1.241. Okay? Now, if I need to move the decimal point from where it is at the end of this number, all the way to the right, to between the 1 and 2, I need to move it 18 spaces over to the left. So that 18 is my exponent. So 1.241 times 10 to the 18th is this number in scientific notation. And that's a lot easier to read. It's also a lot easier to write. How about another example? Here's a number in scientific notation, 5.11 times 10 to the minus 4th grams. I want to turn this back into standard notation. Well, what does the number tell us? The digits that I'm going to use are 511. That's the important part of the number. And the decimal point right now is between the 5 and the first 1. The exponent's negative, and that means that this original number, the number that I'm going to go back to, is less than 1. And in order to make 5.11 less than 1, that means the decimal point has to move to the left. And the -4 tells me that. It's going to get less than 1. A 4 tells me 4 spaces to the left. So it becomes 0.000511 grams. Now the 0 on the left side of the decimal point is optional. I put it in so that it's clear where the decimal point is. You don't have to do that. All right, you try these two. Take these two measurements and convert them into scientific notation. Stop the video and try it. And when you're ready, come back and turn the video back on. All set? Let's see how you did. So 140,000 liters in scientific notation should be 1.4 times 10 to the 5th liters. We moved the decimal point between the 1 and 4. We drop all those placeholding zeros, but we had to move it 5 spaces in to get it between the 1 and the 4, so that's 10 to the 5th. It's positive 5th because 140,000 is greater than 1. How about 0.00252? Well, that's a number less than 1, so the next exponent's going to be negative. The 2, 5, and 2 are important, and we're going to put the decimal point right after the first 2, so that means 3 places in. That means it'll be 10 to the -3rd. Okay, try these two. We'll go the other way. These are numbers in scientific notation. Convert them to standard notation. Go ahead and stop the video and give it a shot. Are you ready? Let's see how you did. 3.32 times 10 to the 7th. That's going to be a number much bigger than 1. So I'm going to move the decimal point out to the right 7 spaces. 33,200,000. That's a big number. 1.0 times 10 to the -5th is less than 1 because of minus 5th power. So I'm going to move the decimal point to the left 5 spaces. 0.00001 grams. Okay? It's really that easy. You just have to practice a little bit and get used to moving the decimal point one way or the other to get into and to get out of scientific notation. So give it some practice. You'll have it in no time.